What type of waves are sound waves? Sound waves are longitudinal waves. Sound waves are longitudinal waves. What is a longitudinal wave? What is a longitudinal wave? A wave in which the particles vibrate in the direction of propagation of the energy is known as longitudinal wave. Longitudinal wave is a wave in which the particles of the medium vibrate parallel to the direction of propagation of the energy. Such a wave is known as longitudinal wave. We have studied that sound wave comprises of compressions and rarefactions. Suppose compressions and rarefactions are traveling from left to right. From left to right in the horizontal direction. In the horizontal direction, the air particles will vibrate along a horizontal line. The air particles vibrate along a horizontal line when the sound wave is propagated. Compressions and rarefactions are propagating along a horizontal direction. How to understand this? Visualize this. How to visualize a longitudinal wave? To understand the propagation, visualization of a longitudinal wave, let us conduct an experiment. Take a long spring, place it on a table. Place it on a table, holding at one end. Compress the spring from one end. Compress the spring at one end and leave it. You notice that the compression will be propagated to the other end. When you leave it, a rarefaction will be formed at the same end. Compression means the rings will come close, the turns will come close to one another. That is called a compression. The coil becomes closer. The coils become closer. It is called a compression. The coils spread apart is called a rarefaction. So when you push it, a compression is formed. That is, the coils become closer. When you leave it, the coils spread wide apart. That is a rarefaction. Both compression and rarefaction, that is closure of the coil and apart, they will transfer. Compression and rarefaction, they travel along the spring to the other end. Like this, compressions and rarefactions will travel in air. In fact, it travels in all the mediums, not only in air. In all the substances, compression and rarefaction will travel like this. Is there any other type of wave? Yes, there is another type of wave known as transverse wave. Transverse wave. By dropping a stone in water, in still water, if you observe the particles, the surface of water, you notice ups and downs traveling along the surface. They are called crest and trough. So they are called disturbance. The disturbance propagates along the surface, but the particles will be moving up and down. So if the particles vibrate perpendicular to the direction of propagation of the disturbance, it is called transverse wave. Light waves are transverse waves. No material medium is necessary for the propagation of light waves. Not for all transverse waves, only for light waves. Medium is not necessary for the propagation of light waves. But mechanical transverse waves need a material medium for their propagation. What are the characteristics of sound wave? To understand sound wave or to study sound wave, we define several parameters. You know, they are the characteristics like frequency, amplitude, speed, etc. First, let us try to understand amplitude. We know that a vibrating particle, it moves its motion is to and fro motion. The longest distance from equilibrium position traveled by the vibrating particle, moved by the vibrating particle, is called its amplitude. While vibrating, a vibrating particle, it moves from equilibrium position to either side. The maximum distance traveled by it is called its amplitude. Similarly, we define amplitude of a wave, sound wave. In sound wave, we notice that pressure and density are varying continuously from a normal value. From a normal value, pressure will be increasing to a maximum value and then it decreases and goes to a minimum value. Similarly, density. Let us represent them by crowded lines and spread out lines. The increase in pressure. The increase in pressure from normal value to the maximum to the peak value is called amplitude. So pressure amplitude. So it is also same as the normal value to the lowest value. Then we come to the wavelength of the sound wave. The wavelength of sound wave. It is the distance between two consecutive compressions or two consecutive rarefactions. It is the distance between two consecutive compressions or consecutive rarefactions. This wavelength is represented by Greek letter lambda. And it is, since it is distance, it is measured in meters in SI system. In SI system, the unit is meter. Then we will pass on to frequency. Frequency. It is nothing but the number of oscillations made by a vibrating body. Then what is an oscillation? In the case of a particle, to and fro motion of a particle is known as one oscillation. In the case of a vibrating body, from equilibrium position to one extreme end, back to the second extreme end, and back to the equilibrium position is known as one oscillation. In the case of a wave, from normal pressure to maximum pressure and then to minimum pressure and then to equilibrium, normal pressure. Such variation of pressure is one oscillation. From normal pressure to maximum, maximum to minimum and then to equilibrium. Such a variation of pressure is one oscillation. The number of such oscillations in unit time, that is in 1 second, is called the frequency of the wave. The frequency of the wave. Or the number of oscillations made by a vibrating body in 1 second. It is also same. The number of oscillations made a vibrating body is equal to the number of oscillations of the wave. These waves, they travel in the medium. While traveling in the medium, if we notice the propagation of these waves at a point, let us name one compression and one rarefaction together as a wave. The distance occupied by a compression and a rarefaction will be lambda, which is wavelength. Let us take such a wave. By the time one oscillation is completed by the wave, then the disturbance travels by a distance lambda. So at a point, number of waves will be crossing. The number of waves crossing a point in 1 second is also equal to the frequency of the wave. The number of waves crossing a point is also equal to the frequency of the wave. Then another parameter is time period of the wave. Time period of the wave. It is the time taken to complete one oscillation. That is, the time required to change the pressure from mean position, average value, normal value to peak value, and then back to lowest value and then to the normal value. Such time is known as period. Period is represented by capital T, and in SI system it is measured in seconds. Frequency is indicated with nu and it is measured in Hz. It is measured in Hz. It is nothing but number of oscillations. The relation between period and frequency is frequency is equal to 1 by period. Frequency nu is equal to 1 by capital T. Capital T is period, nu is frequency. Nu is equal to 1 by T. This is the relation between frequency and period. Characteristics of sound. What are the characteristics of sound? Sound is studied with three characteristics, namely pitch, loudness, and quality. Pitch, loudness, and quality are termed as characteristics of sound. Pitch depends on frequency. Frequency depends on number of oscillations in unit time. If the number of oscillations in unit time is more, we say it is more frequency or high pitch sound. So, pitch depends on frequency. Pitch is nothing but frequency. It is number of oscillations, more number of oscillations made in 1 second. Then loudness. Loudness depends on the amplitude of the sound. Loudness depends on the amplitude of the sound, that is the normal pressure to the maximum pressure. The normal pressure to the maximum pressure. If this value is large, it is a loud sound. If this value is small, it is a soft sound. Loud sound can travel longer distances. Soft sounds cannot travel longer distance. This softness or loudness depends on the mode of vibration. If we hit the table lightly, it produces soft sound. If we hit it hard, a loud sound is produced. Loud sound is produced by hitting the table hard. Like this, we differentiate the loudness. So, opening our mouth, by large opening of the mouth, we will produce loud sound. Whispering is soft sound. Like this, we differentiate the loudness. It is the perception of our brain. The loudness is the perception of the brain. Another character is quality. Quality. It depends on the number of frequencies mixed with one frequency. In sounds, we differentiate musical sounds and noise. A musical sound is a pleasant sound. A sound which is pleasant to the ear is known as a musical sound, and the one which is unpleasant is called a noise. Musical sounds are produced with musical instruments. Musical instrument. A sound of same frequency is known as tone. Tone. And when a musical instrument is vibrated with a frequency, number of multiples of frequencies of the same frequency will be produced along with it, and they will mix with the tone. Such a sound is known as note. Such a sound is known as note. Though the same note is produced from different musical instruments, we can distinguish this note this note with the number of harmonics mixed with it. Such a quality, such a character is known as quality. So we can differentiate with the number of harmonics that are mixed with the note. Such a phenomenon is character is known as quality. Another parameter used in the measurement of sound is intensity. It has a close relation with loudness, but not same as loudness. Intensity is the amount of energy that passes through unit area of cross section in 1 second. The amount of energy that passes speed of sound. When it is traveling, it has definite speed. In a medium, it travels with a particular speed. The speed of sound depends on medium. It travels very fast in solids. Its speed is highest in solids. Its speed in liquids is less than the speed in solids. And its speed in gases is still less than the speed in liquid. So, sound travels with maximum speed in solids, and the speed in liquids is lesser than that of solids, and the speed in gases is still lesser. It also depends on, not only on the medium, it also depends on temperature. In air, the speed of sound is 331 meters per second at 0 degrees centigrade. At 0 degrees centigrade, it is 331 meters per second.